Okay. Do you guys want to get started, or do you just want to wait for Ronaldo?
I'm fine with whatever.
Yeah, I'm fine with whatever as well. So.
Okay, well, let's get started, and if he jumps in, then we can go back.
Sounds good.
Okay. So I will start with number 3. Which hypothesis involves equality? And I put the null hypothesis.
I would agree. Okay, so I can do number 4. So the information it provides, so the p-value is the probability of obtaining a simple statistic, at least as extreme as the one that was actually observed. So question 4, so remember that the p-value is the probability that, so when computing the p-value, which hypothesis do you assume it to be true? And that is the null hypothesis.
I agree.
Suppose the null hypothesis equals 10. Use this information to answer the next 2 questions. Which of the following represents the alternative hypothesis for a two-tailed test? What do they mean a two-tailed test?
The two-tailed is where, I'm really fast. Let me just share my screen.
Oh, the two-sided hypothesis?
So, where did it go?
Yeah, so two-tailed hypothesis is, or a two-tailed test is just where, so like on the first 2, those are one-tailed, or left-tailed, and then right-tailed respectively, because we're trying to find out if the alternative hypothesis is greater than what it actually is, whereas a two-tailed, as long as it's greater or less than what it actually is, we're happy. Does that make sense?
Yeah, so as long as it's not equal to it and not equal to it, it has to be greater or less than.
Mm-hmm. And so this one, the one that would represent, the alternative would be the mean does not equal 10.
Okay.
And that would signify the two-tailed test.
That makes sense.
So this is the diagram that they have in a lesson. So this is the right tail, obviously. Okay. So it's the one that is not equal to, right?
Mm-hmm.
Okay. Which of the following represents the alternative hypothesis for the left tail test? And I put alternative hypothesis mean less than 10.
Yep, I would agree with that.
So the very first one, right?
Yep.
Okay.
And so for that next one, which of the following represents the alternative hypothesis for a right tail test? And that would be the second one. So the mean is greater than 10.
Okay.
Remember that we determine the outcome of an hypothesis test by comparing the p-value to the level of significance using information that represents 2 questions. This relationship would result in the failing to reject the null hypothesis. And that would be if it is less than the level of significance. Was that wrong?
Which one? I can't hear you. Sorry.
Sorry. I said the less than the level of significance.
So the second one?
Yeah.
Was that wrong?
I'm not sure. Jeffrey, do you know on this one?
I don't know. I'm looking it up right now. And so so if the p value is small, so if it's less than, the
Yes.
standard of significance, that means it was a
Yes.
really large z-score, which means we would reject the null hypothesis, I think. And
I
so
think you're
if
right.
if the p-value is large, it means there's a fairly small z-score. So it was actually really close to the original mean. And so we would not reject the null hypothesis because it was actually mostly right. Does that make sense? I'm trying to read up on it and just remind myself right now. I have it open, so I'm trying to, because I cannot remember.
If it's less than it, then we reject it. If it's not less than it, so if it's greater than it, then we
I think,
don't
yes. I'm pretty sure. Okay. Yeah, so if the p-value is less than alpha, if it's less than the level of significance, we reject the null hypothesis. Conversely, if the p-value is greater than alpha, we fail to reject the null hypothesis. So this one, the correct answer would be the first one. So the p-value is greater than the level of significance.
If it's less than alpha, we reject the null.
So if it's less than alpha, we reject the null. If it's greater than alpha, we fail to reject the null.
Yep. Okay.
So we accept the null?
Yeah, so it'd be A, yeah. So the very first one.
Yeah. You know, I'm going to have a hardest time keeping these straight in my head because they're opposite of each other. Everything in this lesson is either or.
Yeah.
And it's just like complete opposite. Oh. Okay.
So
Whose turn is it? Sorry.
I think it's.
I
Is
think
it
it might
mine?
be.
I don't know.
Yeah.
Okay. So which relationship would result in rejecting the null hypothesis? So that would be if the p-value is less than alpha, we reject the null hypothesis.
So the second one.
Yeah.
Perfect. Okay. An insurance company is reviewing its current policy rates. When originally setting the rate, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information to answer the next two questions. Which of the following would be the appropriate alternative for hypothesis alternative? I put the average claim amount is greater than 1,500.
I would agree.
Yeah, that sounds good. Okay. Which of the following would be the appropriate null hypothesis? Oh, I was like, what is that? The same question, but it's not. So it would be the average claim amount is not equal, or I guess less than.
So with the null.
So for the null hypothesis,
yeah.
Go ahead.
Okay. But the nice thing about the null hypothesis is it's the null if it's equal to. And so in this one, it's saying the average claim is equal to 1,500, and so that's how you know it's the null always.
Yeah. No,
because that's our standard that we're basing it off of. So
no matter what, if it's a it's equal.
Yep.
Okay.
Okay. Okay. For question 12. So the insurance company randomly selects 40 claims and calculates a sample mean of 1,650. Use this information to answer the next 3 questions. So the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Does it say anything about the initial population? It doesn't. Okay. I would say, I'm trying to remember, what is it, earlier in the book it said like what standard is like a large sample size. Was it 30 or was it higher than that?
It's 30.
Okay, so I would say it is a good assumption since the sample size is large.
I would agree.
Is what I would say.
I agree.
Okay.
What theorem or law justifies your answer to the previous question? And I put central limit theorem.
So what's the, I can't remember at all. So what is the difference between the law of large numbers and the central limit theorem? Because I know at least two of them, I don't know if it's those two, but I know at least two of them are similar.
Well, it's those two, and I always get them mixed up. So let's go to, hang on, let me just open, I think it was lesson 6-ish. I always want to choose everything for the law of large numbers, but I know that's wrong. So then I always default to the other one. So, okay, here it is. You observed the simulation. Oh, goodness. Why can't it just give me just the the central limit theorem works for every population where the standard deviation is defined. Oh, that doesn't. You have observed in the simulations that if the sample size is large, the random variable x bar will be approximately normally distributed. In other words, the sampling distribution of the sample mean will be normal if the sample size is sufficiently large.
Okay, so that's the central limit theorem.
Yeah.
Sounds good.
Question 13. Which of the following is the test statistic as defined in this lesson? That is Z, right?
I think so. I mean, I'm like really pretty sure, but.
Yeah.
Did you say?
Z.
Yeah.
Did you say X bar?
No, Z.
Is it?
I'm trying to go into it. The test statistic is
totally
Z.
I was totally going to guess X bar.
Because X bar is the sample mean.
Yeah.
The sample size.
And
S. I'm not sure what. I can't remember what S.
Because it's Z equals. Oh, okay. Nope. Yep.
Okay. Z.
Yep. You were right. Absolutely right.
Alrighty. So on to then 15. So the historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with these hypotheses. So the null hypothesis is that the mean is equal to 150. The alternative is that it is less than 150. She used a level of significance of 0.05. She then takes a random sample of 36 sales receipts from her store and computes x equals 144. So the sample mean is 144. What is the z-score associated with this test? So on these ones, it's just calculating the z-score according to, so using, I can't remember, do we use the sample mean or the regular mean on this? So it's the sample mean, right?
So I would use so I think you use the sample mean minus the regular mean, don't you?
To get the z-score.
Uh-huh.
Okay, so it'd be the 144 minus the 150, and then divide it by the 40, or is it the new z-score?
Divided the standard deviation.
Oh yeah.
Divided by the square root, and I think that's
Yeah, so you take
Because-
this, so it'd be
Here, let
40
me-
divided by the square root of 36 to get the new standard.
Screen. Yeah. At least that's how I understood it, is to use that formula.
Okay, let me put this up real quick. Okay, so we would do, just want to talk through this again. So it'd be the 144 minus the 150. And we divide that divided by the original standard deviation of 40 divided by the square root of the sample. So the 36,
Correct.
right? Okay.
Yep.
Just wanted to make sure.
At least that's the way I understood it.
So if I did that right, I got a z-score of 0.9.
Did you get negative 0.9?
Yeah, negative 0.9.
Okay, yep, and it's got to be 3 decimals, so I put negative 0.900.
Sounds good to me. Okay.
So what is associated with the z-score from the previous questions? So I put the negative 0.900 into the applet, and I got 0.184.
So on the p-value, how do you calculate the p-value again? I can't remember.
It's the area, I thought. You put in your z-score into the normal applet, and it's whatever the area.
Is it? Okay.
You know what? I could be wrong because I can't really.
Yeah, okay. So our p-value is the probability that we'd get a z-score that is that. So you're right. Okay.
Mm-hmm. Yep. Okay.
So 0.184.
That's what I got.
Okay. Question 17. What inference would you make about the null hypothesis for this problem? So if it's less, you reject it, right?
Mm-hmm.
So you
Correct.
reject it. Or no. Yeah.
No, because
It's based off the
There
level of
are-
significance.
level of significant is 0.05.
Oh, 0. Oh,
And so we fail to reject it. Yeah.
that makes sense. Okay. Yeah. Okay.
And I don't know if you guys saw, Ronaldo emailed and said he had some appointments and said that he wouldn't be able to make it, which is sort of assumed.
No, I
you know,
didn't.
but yeah.
Okay, thank you.
Okay, so 17, we're failing to reject the null hypothesis, right?
Mhm.
Okay.
Yeah.
18, what is your conclusion for this problem? So we have so we have insufficient evidence that the true population mean is less than 150 because we're failing to reject it, so we have insufficient evidence, right? Or do we, we have sufficient evidence that the true population mean is 150 because we always assume that's right, and so we have to support it, right?
Correct. That's what I put because we failed to reject it, meaning that our
We had sufficient
alternative.
evidence to support that it was true.
Correct.
Okay. Okay.
It's so hard to keep these like straight, right?
Yeah, there's just a lot of different phrasing that he wants. That's wanted in general.
To read negative, double negative, and you're just like, what? Okay, so these are two that confuse me. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting a null when the null hypothesis is true? And I put type 1.
That's what I put. I would agree with that.
Okay, good.
And then the type 2 is just the opposite. When you reject, so type 1 is when you reject a true null hypothesis. Type 2 is when you fail to reject a false null hypothesis.
Correct.
Wait, say that again. Type 1 is when...
So type 1 is when you reject a true null hypothesis. And then type 2 is when you fail to reject a false null hypothesis.
Okay. So type 1, reject it. Type 2, accept it.
Yeah.
Okay. Around 20, yeah. A researcher decided that instead of using the level of significance of 0.05, he will use 0.01. Which of the following will be true? So if instead uses 0.01, it will then be greater than it, right? And so if it's greater than it, then you would not reject it, which means would be type 2 would increase probability. I think
I would think the type 2 error would increase the probability.
Lower the type 1 gets, the more the type 2 gets.
Mm-hmm. And so
it's
in
like
this
a
case,
pendulum kind of.
the type, because what they say about the type errors is that a 0.5 level of significance is a pretty good balance between the two probabilities of having a type 1 versus type 2. And so if you go up, you have less of a chance of a type 2, but more of a chance of a type 1. Or in this case, you go down, so you have less of a chance of a type 1, more chance of a type 2.
Okay.
I agree.
So type 2 would increase.
Yeah.
Yes.
All right. And then, so if alpha, so the level of significance, equals 0.05, compute the probability of committing a type 1 error. So that would be, the chances, I would assume, so we're basically trying to find statistically the chance that a type 1 is when we fail to, or we reject a true hypothesis, right? Reject a true null is type 1
Correct.
error. Yeah. And so the chances of this, wouldn't it just be 0.05? So it'd be 5% chance? Or would it be different? I don't know. Let's see.
Trying to find, okay, the level of significance is a standard determining whether the null or not the null hypothesis should be rejected. Typical values for five 5.1 if less alpha is not less than which. Okay, that didn't answer my question though.
Okay, so the most common value we chose alpha to be a small number, so the probability of committing a type 1 error is low. The most common value for alpha is 0.05. This is equal to 1/20th. Dang. So there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance. And so it'd be a 1 out of 20, so a 5% chance. Right?
Okay, let's read the question again. Now I've forgotten the question. Compute the probability of, yeah. Oh, I'm trying to think of it being like the opposite. If we have 0.05 type error, then what would it be for type 2? So yes, it's 0.05, right?
I would imagine it doesn't say anything else in
Yeah.
here. I'm trying to, I mean, there's no conversion or
No.
anything, so that's what I would put.
Mm-mm.
I would just put 0.05 as far as committing a type 1 error.
Nope. Yep, that's what I'm going to put.
Okay. Okay, that should be it. And by should be, I mean that's the whole thing. So,
Right.
all right, I am going to start submitting it then. So we got question 18 wrong, but that was the only one. And that is, what is your conclusion for this problem? Whether it's that we have insufficient evidence or we have sufficient evidence.
Mm-hmm.
And so we have sufficient evidence that the true population mean is 150, and that wasn't right. So I don't know what he really wanted. So maybe it was that we have insufficient evidence that the true population mean is less than 150. I don't know. I don't really care because it's only one question, but
We put that it was less and that was wrong.
well, so we put on 18, at least what I put was the second one in. So we have sufficient evidence that the true population mean is 150 because that's sort of what we had decided, but on 18, but
Okay. My
it
computer
might,
leaked out, so I haven't submitted it yet.
yeah, okay.
Okay, well, I had to refresh my page because mine wouldn't save. Nothing would save, nothing would
Hey.
submit.
That's what happened to mine, Danny. So I was like, what the heck?
It did?
Yeah.
Oh, it was.
My last
Yeah,
three
I totally
questions
had to
were
refresh mine. Oh, and now I have to go back because, okay, so on 20, does anybody remember what we put on 20?
the probability of type 2 error will increase.
Okay.
And that is correct.
Okay. 0.05 on the last one, and we
Yep.
got 18 wrong, right?
Yeah, but I'm kind of curious, if you do the third one in, so we have insufficient evidence that the true population mean is less than 150, I think that might be right, but I'm not sure.
Okay. Well, I'm going to try that one. And I'm not trying this because we're cheating. We had technical difficulties just for the population to know. Okay.
I have mine submitted now.
All right.
Yeah, that one's right for 18. We have insufficient evidence that the true population mean is less than 150.
Way to go. Yep.
Oh, well, I got one wrong. I don't care at all, so.
Way to take one for the team, buddy.
That's what I'm here for.
All right. I guess I'll see you guys next week.
Alrighty, see you next week.
I'll turn this in, so we're good.
Thanks,
Awesome,
Danny.
thank you so much. Alrighty,
Yep.
see you guys.
See ya.
Have a good weekend, guys.
You too. Bye.
You.